Hello class, it's Dr. Mike here. So a few things here about creating partitions. So creating partitions themselves, when can we do it? Well, normally the best place to do this is, of course, during installation. And installation is going to vary. You'll see here there is the GUI here, and this looks like it's CentOS. It's going to look different for each distribution, but most of the time there's going to be a thing here where you could do a custom layout, and that's the thing you want to look for. And here you'll dictate the mount point, system type, and the size. So again, and the idea being, if you looked at my previous video I just recorded, and it was about schemes and partitioning, you'll have the layout you'll need. You'll know you'll need a mount point of so much size. So you'll have that laid out, ready to go, or you'll be given sometimes some guidelines on what should be partitioned of what size and what type of file system it should be. So there's some examples here. You can see they created it's like 1 gig here for root, and we have 500 megabytes for var. These are tiny, and we have 200 megabytes for home. And you can see there's some options here: fill the maximum level space, up to a certain amount of space, and so on. So pretty straightforward. And again, the best way to get this is during install. Now you can also do it after installation. And primary tool we're going to look at here will be Fdisk. Now Fdisk-L is fantastic for just viewing your, not just your partitions, but also all your devices. So if I have any unused devices, we'll see them show up, and in there I can get the capacity of the actual device. It's a 21.5 gigabyte disk, looks like. The heads, the sectors, and so on. And also the sector sizes. So these can be very useful in computing some little detailed things about the disk. But overall, just I have div SDA. It has 21.5 total gigs. And you can see here I have these partitions laid. I have these partitions for them. We see the partition number, and there's our naming convention, right? SDA. Start end sector, the block number of blocks. The ID is a list of, and we'll see this, a list of all file system types. This is like AU3 is, I believe, ext3. And then the type of system is, this is an extended partition. In this case, they took SDA2, a little odd, because you see this on 4. But they made it extended, and AE2 is a swap. So you'll see this. You can identify all types. And again, this does not actually format it. This sort of marks it as format for this file system type. So where else -L output. Yeah. So Fdisk. There's a lot of tools. Fdisk, SFdisk. Maybe I'll show you 2 of them here. Gparted, parted. So Fdisk is really sort of the bare bones tool for formatting your partitions, for creating partitions. It has a really minimal interface. So this is interactive mode, and we'll use minimal interactive mode. I'll show you that. So I won't go through all these commands, but just to know, probably the one command you need to know is, and it's odd, M for help, not H, M. So this will give you an idea of what commands can be done. So, and then we'll just go and do this. So let's actually look at creating a partition. So here we are. Again, first off, make sure you're a root user. Partitioning definitely needs to be done at a root level system. So here, ls-l, dev sd splat. So I have dev sdc. So let's take a look at that. So first off, fdisk-l will show me, you see it's not interactive. I come back to the command prompt, so there's no interactivity with -l. And you can see it tells me I have dev SDA, it's a 17.2 gig disk, SDB is 21.5, and so on. And SD A has 2 partitions already. Here we see a Linux LVM. And we'll actually, in the next video, and the one coming up here, we'll do LVM separately. And here we have a Linux partition type AU3. What we'll do is we'll take SDC. These rests are empty. We'll skip dev mapper and VG. These are all volume groups used for logical volume management. This last one here, dev SDC. So it's a pretty small disk, like 5.368 meg. We'll grab this. We'll make some really small partitions. So let's start off. So first off, Fdisk, and I want to do dev SDC. So I identify the disk I want to actually partition. And you can see here, note, changes remain in memory only until you write them to the actual back to the partition table. So again, M for help. Very handy. So first off, we can do P to print. Let's print our current partition table, which is nothing. So we'll go and do N for new. So here you can see you can create up to 4 primary and multiple extended. So this goes back to how the partition table, what it can hold. The partition table has enough space to hold the location identifiers for 4 primary partitions. So for now, we'll use primary. We'll create 2 quick N for new. And now what type do I want to do? Default's primary. So that's fine. We'll take the default primary. What number do I want to use? Number 1. Again, you notice we're going to use the defaults here. Most of the time, Fdisk sort of tells you what it knows is best. For now, 1. So here's our actual sectors. Now, I'm not going to get into the nitty-gritty about calculating the end sector or default sector. We'll show you how this works. First off, just grab the first sector. There's almost very little need to create a sector, a new partition in sectors outside of the existing sector, start sector block. Hence, I'm not going to start at sector 49.6 when 2048 is available. So again, take the default 2048. And here, of course, I can say how many sectors I want. So I'm not going to go through it and compute the 512 byte sector size times the number of sectors I need, and so on. Best thing is to use the plus size. And you can see here it's plus size, so in M, kilobytes, megabytes, gigabytes. So for example, I do plus, let's do 200 megabytes. And you see it's set. Do P to print. You see now dev SDC1 has been selected for me, or set. So the 1 again comes from the partition number used, 1. Start size and end sector, those are great. Again, that's more about the size I want. Now, heads up here, because of the way we have the 1024 sectoring, it's 1024 in computing in general. You know, you want exactly 500 megabytes. You might not get that. You might get a little bit less, a little bit more. That's normal because of the rounding of 1024. So first off, this is great. Let's use this. Now, again, here's the ID. Yeah, it's already set to default Linux, a Linux file system type. If I wanted to, I'm here, I can go ahead and say list known partition types, and then I can actually change the system ID. And so I did T. In this case, I can do L to list all of them. This is not looking good here. Let's maximize that. Let's do it again. There we go. So you can see here 83, which is Linux. And for our case here, it's perfect. That's all we need. But if I was making a logical volume, I would need to actually identify or make a swap. It would be 82. Or it's LVM, 80E. So these are hexadecimal codes. So again, we're using 83. It's been set. It was set before, but just do print to verify it. And that's it. So okay, we create our partition. And when we're done, we need to write the table and exit. So use W. That's it. Now here's a note here. The partition table itself has been changed on disk, but our kernel does not know the changes. The kernel has a snapshot of the partition table in memory, so we need to tell the kernel to reread it. Two ways to do this. One is a reboot. It's a little heavy-handed, but there's actually a command we can run called part probe. Of course, there's a root, I can run it. Now, you don't see anything, you don't get any feedback, that's good. All part probe does is it probes the partition table again and updates the kernel. If I don't do part probe or reboot and I try the next few steps, I will get an error. It will not see SDC1. So just keep a note of that. So again, let's look at Fdisk-L, and we can see now SDC has 1 is created. Our next step. Now we identified this as a Linux partition type, AE3. So we'll take ext4. It's a pretty common formatting to use. And then you need to format this. To format it, let's do this. We use mkfs, or makefs command. So mkfs has a couple ways to do it. If it's undefined, you can do -t. If it's undefined, it will use ext2, so keep that in mind. If I want ext4, I gotta make sure I tell it that. There's some things we can do. We can actually set the block size. So the block, what is the block? The block is the smallest unit of writable disk. So if I have a file that is 1024 bits in size and it writes to a block size of 512, I need 2 blocks. If I write a 70 byte file to disk, it's going to write to 1 block, but it's going to use that space as sort of wasted space. It's called slack space sometimes. This is probably a little more extended here. Most of the time, just take the default block size. But let's say, for example, I am making a database. A partition for a database. Let's say /data, I'm going to call it. And I want to figure out the block size for /data. Well, I might look at what's the largest or smallest or average size of the objects that the database is going to write out. Let's say it's 1024. So all I might do is I might match the block size to the average size of the objects being written, the bulk of the average size. This will increase your input-output because there's less reads of the disk itself. Now, this is real finite stuff here. With SSDs, I mean, we got speed, but should be not a problem, but something you can consider, and that's why you might change block size. But for now, though, I'm not going to worry about it. So I'll show you a shortcut. mkfs.tab a couple times. So save myself from typing mkfs space -t, ext4, and so on. I can just put mkfs.ext4. ext4. And then what I want to partition. I want to partition dev SDC1. And that's it. So you can use the mkfs with the -t and then identify ext4, or just do this, mkfs dot, and hit tab. You'll see it's got some of the commonly used stuff, vfat, xfs, ntfs, minix, and so on, and ext4, 3 and 2, sort of laid out for you. So it's a shortcut. Either way works. You can use -t, or you can use this format. So we can see here, it actually partitioned it. Now this was a, what, 200 megabyte partition, so really small. It takes maybe 5-6 more seconds longer on large partitions. It's nothing extensive, but it does create the inodes and the blocks per group and our super blocks. So that's probably the inode level. For now, though, we're done. This is actually a writable system. So let's talk about mounting real quick. So we do a separate video about mounting, but let's do it real quick here also. Nothing wrong with reviewing that. So first off, I'm going to make a directory called data. I made that off /. So if I do ls-l, here you can see, here's data. I'm going to show you a trick here. I don't want people to write to this directory while there's nothing mounted to it. Right now it's writable, at least by root. So I'm going to chmod 00 / data. Now you can see I have zeroed out the permissions. Think to yourself, well, now it's not usable, is it? Well, it will be. Let's mount this. So our mount command, mount. I put the device in the directory. So I want my dev sdc1 to /data. If I do df-h, we can see there it is. It's again 199 megabytes. Again, we have a little bit under the 200 megabyte mark. That's fine. It's normal. SDC1 is mounted to /data, and it's now usable. And if I do ls-l /, you notice the permissions are back. So when mount is enacted, it actually reapplies permissions. So what this means is if I unmount this, it'll go back to all zeros. So let's say I have this partition unmounted for some reason, maybe for maintenance or whatever reason. I don't want an app or someone writing to that partition. I can, when I unmount it, which is umount /data, you can see it's gone back to unwritable. So it's a way to protect that. And it's actually common to maybe have a mount point, a small partition for mount points. That way, if something does get unmounted and something is writing to that mount point, it fills up the mount point, not the root partition. So again, back to our scheme, our Zionist scheme. For now, though, I mount it. And I can df-h. You can see it's there. I can see it as /data. And we're good to go. We can copy files here. Copy from root. What do we have here? We have, take the Anaconda file. We'll copy that here. And I may wonder what happens if you unmount it and there's something there. Let's unmount that. Oh, it's busy. That's good. So we'll see this in the mount thing. If something's using it or someone's inside that directory, you can unmount it. So let's get out of that directory. Again, so by ls/data, it's gone. The file's gone. It's not gone. It's still there. Just now /data is sitting as an actual directory on root. When you remount it, it will be there. So, and there it is. It's back. So we didn't lose the files. They're still actually written to that partition on disk. However, when you unmount it, you don't see them. So, and that's it for this. Now we will do LVM on a separate video. Thanks.